Assalamualaikum and good morning to everyone. Thank you for participating in our class, SKEE 2133 section 03 and 04. Before that, I hope everyone is coping with the MCO, and you guys, I hope that you are well and also keep your health, okay, as best as possible. Okay. I have already set up the e-portfolio page or group, and I have seen one submission. Thank you for, I think Khalid had post a reflection. So that could be a good beginning for our e-portfolio. Then you can continue. Actually, our class, I do not have a lot of worry about our class because we had covered the lab session, and that is all, and at the same time that should cover assessment, most of the assessment for your course marks. Maybe we have some issues and challenges in implementing the test. Okay. Okay, a few of you maybe cannot hear. Maybe the line is not very good. But anyway, I'm recording this lesson. I am recording this lesson. And also, I will upload it in the e-learning. I cannot hope for the best for everyone. So I know there will be a lot of disruption, especially in the internet. Maybe if you want to have a good connection, you can disable your video. Okay, you just disable your video, but make sure that you can listen to the class, to my class especially. Okay. Right. Coming back to the test, there were some discussion. There was some discussion in the department. Probably we will conduct online tests, or maybe we can conduct the test after you return to UTM, and then that could happen after the Raya break. That's very long time to reach, but maybe we're going to do the online test evaluation. We will tell you how we will conduct the test later. Okay. Basically, if we look at our class, we already covered 4 main chapters. Okay, metrology up until digital instruments. Okay, so 3 more chapters to go. Interfacing, noise, and transducer. So I don't think we're going to have a lot of problem to finish our class. And I think you have already aware that our semester is stretched. Let's stretch until so we are going to have like 22 weeks. 22 weeks. Okay. And most of you probably have to come back after the Raya break to complete your lab. I mean, not our class lab. I mean your program lab, right? And today we will be talking. Hang on. Okay. Today we'll be talking about interfacing. Okay, interfacing. So let's start uh, from let's start by describing the end of the topic at the beginning. So basically, what we want to know is how instrument communicate. Okay, that's the idea. Okay, so in instrumentation, in instrument electrical instrumentation, so we have basically sensors communicate with devices, and also device communicate with other device. We want to see how the principle of how devices communicate with each other, and we want to see how the process of the interface evolve, okay, from basic up until to the uh, complex system. This is basically interface is a dynamic topic. Okay, it means that there will always be a new uh, area in the interface, especially in what we call as the protocol. Okay, protocol means the standard of communication, okay, between devices. Okay, so I think when I say interface, you can think of like USB. Okay, USB, and then we have different version of USB 2.0, 3.0. Okay, but there are many others communication, communication in that communication, and that covered in the interface topic. But we will look into uh, the basic and then important types of communication standard, which will be the tools that will be the main thing we will discuss in this class. Okay, so the idea is, okay, we have when we do communication, okay, basically we want, okay, we have like the a device, okay, device one, we have a device, okay, we want to communicate with other devices, okay, device. So basically, transmission media is the physical or non-physical connection between the devices. Okay, okay. So this in media, or the media can be physical, or can be physical, or non-physical. Okay. So the idea is, before we can transmit the information from one device to another device, okay, that information must be encoded. In other way, in other words, it must be converted. Okay, it must be converted into another form of energy. Okay, and it is converted into a form of energy, or that is transferred through physical, like wires, okay, or non-physical, like our wireless connection. And then when it receives to the device, it will reconverted or decode. Okay, we have to decode back that information. So the information come in a form of energy, so we need to reconvert. Okay, so the energy can be electrical, like electrical signals. Also, it can be in a light form. Okay, where we convert the information into high you know, high or low or patterns. Okay, and also it can be modulated. Okay, the information can be modulated uh, on a radio wave, then transmit into the air or into the atmosphere, uh, and then receive by a device or a receiver. Also, it can form of sound. It's like I'm talking. That is also a form of transmitting information. Okay, it's a form of encoding my information into a sound. Sound basically is a sound wave, you know, sound wave, high and low pitch, different frequency. Okay, so this energy have different properties and requirement for transmission. Okay, so this transmitted energy is carried through some sort of medium. There must be a medium, and basically, okay, the media in general it can be like solid, okay, also it can be a form of gas, okay, okay, and also it can be a vacuum in some form of energy. It can travel through vacuum. Okay, vacuum also possible, like uh, like in the outer space, right? So the basically our data is transmitted through a relay tower, and then relay tower transmit, okay, back to the radio communication station. This is communication relay to the satellite. When it relay to the satellite, it basically travel through the vacuum. So some of the energy is possible to travel through vacuum. Like also light, okay, light like light like from the sun, so travel million kilometer away, okay, to then reach upon our earth surface, also a form of energy transmission. So but we want to see the in our class here is how energy is carried through some sort of medium, and the basically what we have a transmitter that encode the data. So we have a set of data, okay. So we have a set of data, and then with the data, okay, we have a circuit, okay. A transmitter basically a circuit, electrical circuit, okay. Sorry about it. Okay. So we have a circuit, electrical circuit here. Okay, this electrical circuit will encode, okay, translate that in the form of high and low. For example, high and low electrical signal, high and low, and then it is transmit through in the form of energy, okay, through a medium like for example a wire which is a copper, and then at the receiving part we have a receiver. Okay, a receiver is also a set of another circuit. Okay, this is another circuit. Okay, so we are not going to discuss how to build the circuit, but what we're going to discuss how the principle work. Okay, how the principle work, and then the receiver will decode the data, and then the user will, okay, see the data which is sent from the transmitter. Okay, this is the most common part or common transmission medium. It's copper or copper wire. Okay, we have, uh, for example, twisted pair uses two wires. Okay, so the reason, okay, in communication or in an interface, the reason why we twist the wire, there are several reasons. First is to increase the increase the durability. Okay, increase the strength, the durability. Okay. Another reason why we twist the wire is to cancel or reduce the noise. We try to cancel or reduce the noise. Okay, basically the wire, it will carry current. Okay, they will carry current. Okay, in different basically different direction. Okay, let's say this one positive is one negative. So the wire will, Fleming's law, there will be electromagnetic field produced. Okay, and then if we twist the cable, it will virtually cancel out the noise. Okay, that's another reason why we twisted the wire. Okay, increase the durability, cancel the noise, and also other reason for tidy. We want to manage. Okay, we want to manage it properly. So it's a matter of having a good set of connection. Okay. So there are other type of higher standard of copper wire. Okay, for example, what is called as the coaxial cable. Okay, this coaxial cable you can see in the common lab. Okay, for example, the I think you have played with the coaxial cable, like what oscilloscope, okay, oscilloscope cable. Okay, so but the basic principle we have, like what we seen here in the middle. Okay, in the middle here, okay, is the copper wire. Okay, the inner wire, and then is strengthened by an insulation. Okay, the insulation basically this is made of plastic material or polymer. Okay, plastic okay, plastic material. Okay, and then it has a metal shield. So this is to basically to make sure there's nothing coming in or coming out from the wire. Okay, so basically is to reduce noise lah, reduce noise, or to avoid any interference caused by the connection itself. And also we have the outer insulation. So outer insulation normally is in a black color. Okay, black color. As you can see from the top left here, it's black color. Okay, so that's a basic outer insulation. This is for the first protection. Okay, for the cable. Okay. Oh yes, it's used in mainly, you can see a lot of in oscilloscope. Okay. And I forgot to say the metal shield is basically is grounded. This is grounded, grounded. Okay. So any signal induced from outside or from the wire itself will not, interfere each other. So basically anything from the wire or anything from outside the wire, okay, will terminate on the metal shield and then go to the ground. Okay, so they will make sure to reduce the noise. Okay, so next we have glass fiber as a transmission media. Okay, glass fiber. This one we use light energy to encode the data. So the medium is basically glass fiber. So glass fiber, which this principle of Snell Snell principle. I think Snell principle. Snell principle in the optical physics. The physics is Snell, where you when the incident light will refract, okay, at a certain angle. Okay, it will reflect at a certain angle. Okay, so it basically is a fiber, glass fiber, that can carry light with encoded data. Okay, so in the middle, this is the fiber, and then you have insulation as a protection, and some modem or communication Maxis fiber connection 4G, for example, they are using this fiber. Okay, but in the real world, we need an extra protection, uh, like a metal, uh, like a metal jacket or metal tube or something, because this is very fragile. Okay, very fragile. It can be easily beaten by rats, for example. So we need extra protection. Uh, so the on the transmitter, actually basically we have LED or laser injection light. Okay, this LED basically, okay, it's connected to a certain circuit. Okay, there's a, okay, for example, there are signals, and then the light, okay, will turn on and off, or bright and dim according to the signal level. So this signal level will go through the uh, glass fiber, reflect up to the end. Okay, so I think the good thing about and then I will explain later what is the advantage of the fiberglass later. But we see the some advantages of copper. Okay, basically uh, copper itself is light in weight. Okay, means okay, but if you compare with optical fiber is basically also lighter than copper. But when in the industry, when you use fiber optic, you have to put it inside the tubing. Okay, but for copper, so they shouldn't they are not they are the the construction is already sturdy, already tough. So you don't have to put extra protection to the copper itself. Okay. No spark if the insulation is good. Okay, not. Oh, sorry, there's a optical fiber. Okay, optical fiber uh, is much better than copper, light in weight, but in practical, okay, basically in practical, like I said, there could be some tubing. So it could be a bit a bit tricky lah to use fiber optic. Okay, and also in optical fiber, there is no less risk of spark. I mean, there is no risk of electrical spark. Okay, no, especially if you use copper. Okay, copper, you have to make sure you have to make sure the insulation is good. Okay, you have to make sure the insulation, you have to check. But there's a slight exposure on the insulation. So if the wires are touching together, it can cause spark. Okay, cable size for optical is much smaller, but like I said, usually they do not come just the fiber optic itself. Okay, it comes with the tubing. Okay, And also fiber optic are resistant to corrosion lah. They are do not oxidize lah. Do not oxidize like a normal copper wire. Okay, that is the advantage I want to add about fiber optic. Why fiber optic? There are a few disadvantages lah. Disadvantages about fiber optic is one is the cost. Okay, the cost of the system. Cost of the system. This is the disadvantages. Disadvantages mean the negative point. Okay, cost of the whole system. Cost of the cost of the whole system. Sorry. Okay, so in optical fiber, optical communication, we have a encoder. Okay, again, and the fiber optic itself, and then we have a decoder. Okay, encoder, decoder. These two set of circuitry, they are very expensive, very expensive. In terms of the wire, the connection cheap. Okay, fiber optic is cheap. Fiber optic is cheap. Okay, but the circuitry, the encoder and decoder of fiber optic are very expensive. Especially now we are moving into like 5G, 5G. But I think over time, due to the advance of communication and electronic area, so that the cost will go down. Number two, the advantages is the what is called as dB attenuation. Okay, attenuation. Okay, simply I put simply like this. When you see a source of light, let's say you see, you are driving a car, you see a lamp. Okay, the street lamp, the street light. So as we move away from the street lamp, so it become dimmer. So the same principle, once the transmitter transmit the signal or the light into the fiber optic, it will attenuate. Okay, attenuate. So we need, usually in optical fiber interface, they put a repeater. Okay, in the middle here. Okay, for example, we put a repeater. So a repeater. Okay. So we put a repeater. So the purpose of the repeater is to increase or to to make sure the light intensity return to its original level. So it's recovering the strength of the signal. Okay. Okay. Next, we move to radio. Radio data is transmitted using radio wave. Okay, this energy travel through the air, through the open space, rather like copper or glass. So this is very pervasive. We see it every day around us, and we are currently basically using it right now. So it's similar to radio, TV, and your hand smartphone. Radio frequency, the good things can travel through wall, and then it can permeate. Okay, it can distribute through an entire building, depending on the strength of the radio signals. Okay, it can be a long distance or short distance. Okay, similar like fiber optic. If it's very long distance, you can use a repeater. Okay, repeaters. You set up a station and you repeat the signal. Okay, for long distance, usually they will use a satellite relay, okay, where the signal will be transmitted through ground station through the satellite and transmit back to another ground station on the opposite side of the world. Okay. Okay, so short distance, we basically use a wireless computer network for point-to-point communication, like a router to your PC that can go up to 10 meters or 15 meters, depending on the specification. Okay, so an upgrade of radio wave, we have microwave. So the difference is that the frequency level, okay, frequency range, okay, the frequency is basically higher than a normal radio wave, and you know, and but microwave at some extent, okay, they can transmit a higher energy. Okay, this is what we have in our normal microwave oven. And this is a unidirection. Unidirection means that it can only communicate, okay, like you have one device, okay, transmitter, one device, transmitter, sorry, you have device one, okay, you have device two, okay. Microwave means that, okay, only one device can play a role as a transmitter and another one as a receiver, or one talk and one receive. And then it can change the role, but in another set of transmission, one is the receiver, one is the transmitter. That is what it means by unidirectional. So they cannot talk and listen at the same time. Okay. And usually microwave, we have a big antenna, okay, mounted on the tower to where we relay the transmitted data. Infrared, this is the common, or the low cost, where and many specialized device still using infrared. Okay, especially what we have in our TV remote control. Okay, so infrared is basically safe. Okay, level energy. Where we can don't have to have any worry to use, okay, in our daily life. We can propagate through room. Okay, the propagate means that if you point your remote control, okay, other way around, it can still reflect, okay, bounce, and then your TV still can receive the signal. Okay, but basically they cannot penetrate. They are not strong enough to penetrate walls. Okay, I think this is very old term, PDA. Even during my time, but now with your smartphone, some smartphone they have like embedded infrared transmitter and receiver. Some smartphone. Okay. Okay, laser. Okay, also an advanced, okay, interface of system. In unidirection, just one device talk and another device listen, vice versa. Okay, but they are basically high speed. Okay, in microwave, usually they is used in the outer space. Okay, outer space exploration, in outer space communication between a satellite that is launched into the orbit and go beyond our galaxy. So they basically communicate through, and they can communicate through laser interface. Okay. But if you use in our atmosphere, it's not very, the tricky part is it's can adversely affected by the weather. So laser basically is optical base. Okay, optical base. Optical, okay, base. So you can check what the Beer-Lambert law, Beer-Lambert law, Beer-Lambert law, where light, okay, basically attenuate when it traverse through the open space. Okay, so basically the intensity is inversely proportional to the length or travel or length of distance. Okay, intensity is basically inversely proportional to the length of distance. Okay. Okay, how to choose a medium? Depends on your application and practicality lah. Whatever you want to decide, basically they are okay to choose a medium. The first thing is the practicality lah, your design. Okay, and then also the requirement of your design. Okay, let's say your design require a very minimum connection. So very minimum connection, probably you can use wireless. But in some application, wireless is not very recommended. Especially, for example, if you want to build a device, okay, that use wireless communication, okay, but you want to use in the hospital. So in hospital, you have a lot of sensitive device, okay, equipment. So they are very easily interrupted by other signal. So maybe you cannot use wireless in such condition. Okay. So those are a few thing that you can consider. And I think the last thing you can consider is the cost. Okay, some people maybe think cost is number one, but to me, cost is the least that you can put into. Okay, everything you have to consider is first the practicality, the specification in mean the design of the system, also the requirement. You have to think about the noise. Okay, you think the interference. Okay, you also need to think about the dimension. Okay, and how big is the area, for example, how long is the communication distance, and so on. Okay, okay, timing transmission basically is speed. This is what this is this is uh, communication speed. Okay, this is talk about communication speed, and also how what is the best way, what is the best protocol that we can use to as a communication standard lah. Okay, so depending on the system. Okay, like in communication, you must have the very fast. You have to use a very fast communication standard. Okay, there are many communication standard established by organization. Okay, like IEEE, like the most common one is the IEEE. Okay, IEEE, like if you look at the USB, okay, you look at the specification, there is a prefix, okay, IEEE, like that, IEEE. Okay, so if you are a very good computer programmer, and then you you like to do a lot of work in communication area, so these communication standard they are basically open for people to give opinion and do improvements. Okay. Uh, okay, and then we want to talk about bitwise data transmission. What bitwise is basically, we send binary information. Okay, we will send binary stream. Okay, binary stream, a set of data from one device to another device. Okay. So the basically this in device communication, we are only sending 10101010. Okay, but this data, okay, there are two common transmission type. First is the parallel, okay. Second one is the serial, okay. Parallel, it send data several bit at a time. Like for example, what you will see in this figure on the left, okay. So there's a PC send a parallel data to a printer, okay. Okay, means one set of data, okay. Parallel transmission, it sends faster, okay, faster. Data is faster, but expensive. Okay, expensive because we have to prepare a bigger port, okay, a bigger connection for a parallel transmission. But in my experience, during my time, I don't know whether PC, I haven't checked. Okay, a normal PC usually it comes with a parallel port and also a serial port. I don't know if it is still available. I'm not sure. I haven't checked it up until today. But during my time, there was no. During my time, there was no USB. I mean, USB came little late lah. During my time, 1998, we only have serial and transmission, serial and parallel. When we have to choose between serial and parallel. But in my experience, parallel communication is much, in terms of the protocol, if you want to write the code, it's much simpler, parallel. But like I said, it's a bit more expensive because you have to use a lot of, you have more wires. Okay, you have to more, and also the one of the thing that we were worried when we're using parallel is safety. Okay, parallel, you can easily, you know, faulty, they easily they get faulty. If there is any faulty in the line or the connection, okay, probably our motherboard will toasted, you know. We have to change our motherboard, and that's why there's another option, which is serial communication. Serial communication send data one bit at a time, so it sends a stream of data basically. Okay, data transfer is slow in our perception. We basically cannot see how, even we cannot comprehend how the in our naked eye how the data transfer. But in terms of the device communication, is quite actually a bit slower. But the best thing is simple and cheap. But the complexity, or I mean the challenge about serial is the coding complexity. The coding, in terms of the coding, is a bit complex for serial serial transmission. Okay. So far, do you can cope with the class? Okay, you can. It's okay if you want to interrupt. I'm okay. If you want to immediately interrupt during my class, if you want to ask question, I have no problem. Okay. So next we have the asynchronous communication. Okay, asynchronous means that transmitter and receiver do not explicitly coordinate, okay, each data transmission. Okay. So if you have anything to ask, you can just drop the. Let's see how I can see chat. Okay. Okay. Can see the chat. Right. Hang on. I will. Okay. I have a question. Do we have a test one? Okay. I will. Basically, we going to have test one. There will be must at least one test. At least one test. We must have one test. But the implementation, we are still in this subject. We are still thinking whether whether to do it in online or to do it after you guys return after the semester break. But we have to think this carefully. I think how the best way to conduct the test one. But there must at least must be one test. Okay, we are expecting to have one test. Okay. Okay, coming back to the lesson. So we have asynchronous. Asynchronous means that what? Which part? Which part? I think I was talk. Okay, the difference between the parallel and series. Okay, let me return. Okay, the last part in terms of the coding complexity, coding. Serial transmission, okay, require much more complex coding. You do coding, okay, you want to code. Okay, let's say you want to communicate your you want to code a microcontroller to communicate with a device, another device. So the coding through, let's say you want to do it, so do it in serious communication. So the coding is much more complex. The coding in C programming or other type of machine languages. The coding is much more complex. Okay. Right. So come, I think that answer the question. So asynchronous communication, okay, in other words, this is a not real time. Okay? It's not real time. It means asynchronous means the data is delayed. It means it's not coming in a real time. It's coming with some delay. Okay. So basically, the transmitters will when it transmit the data, it will take some time for the data to be fully transmitted to the receiver. Okay, so this is what it means by asynchronous. Okay, synchronous means that when data set comes in almost immediately. Okay, in virtually immediately or in real time. Okay, so in asynchronous, we basically use electrical current to send bits. Okay, so we are talking about voltage level. Okay, voltage level. Okay, so simple, you can remember. Okay, when the voltage level is negative. Okay, negative, as I've seen in this figure, that represent 1 bit. Okay, 1 bit, low level, low voltage. Okay, low voltage, that represent bit bit information 1. Okay, whereas okay, high high voltage, okay, that is basically representing 0 bit. Okay, 0 bit. Okay, that is in terms of voltage level translated into binary value. Okay, binary value. So you have to remember that negative voltage level means 1 binary value. Okay, positive or high voltage level means 0. Okay, 0 binary value. Okay, now maybe I will just this is going to be the last slide for today, and then inshallah we will continue tomorrow. So RS23232, okay, this is a standard for transfer of character using copper wire. Okay, it is produced by EIA, the Electronic International Association, in 1962. It's quite old. I mean, old if you think of the time it appeared, but basically RS232 still relevant up to date. Okay, we may not see it in our laptop or your smartphone, but many specialized devices still use RS232. For example, the scanner they use in the shopping or the retail shop. Okay, the scanner. So they are basically using RS232 connection connected to the PC. Okay, there are other like laboratory equipment that's still using RS232. Okay, so it's still relevant up to today, and I think it will stay relevant today. Okay, even you might surprise that inside the spacecraft or in the space station, they are still using the RS232 communication. Okay. So the RS232 means that serial asynchronous communication. Serial means data is sent through a serial communication, and asynchronous means that there will be some time delay. Okay, time delay, or there will be time of period for the data to be fully transmitted from a receiver to a transmitter. Okay, so bits are basically encoded and transmitted one at a time. Okay, we will see a few examples of that later tomorrow, inshallah. Okay, asynchronous, like I say, a character can be sent at any time. Okay, so mean that the receiver, okay, just wait for a confirmation bit. Okay, we will see the details that soon. Okay, in the class tomorrow. Okay, like I said, it's still widely used. Okay, it may not be boldly seen anywhere in your daily life, but it is still working. Under our conscious especially in specialized equipment lah. All right. Okay, I think I will stop our lesson for today. Hang on. So I can see in our class, there are 14 guys. Okay, thank you today for participating or being in the class today. What we all do, I know that other of our friend might have problems or might have challenges. So what I do, I will check with the WhatsApp and then approach one by one, and then I want to tally with our, match with our registration. So I want to see. Okay, so thank you everyone. It's okay if you have any question. Like I said, you can interrupt me anytime, and also you can drop any question in the WhatsApp. Okay, also you can drop it in the e-learning or in the e-portfolio. Please continue to do your assignment. Okay, so we see you again tomorrow. Thank you very much.